What's going on, everybody, and welcome to part 9 of our AI in StarCraft 2 with Python tutorial series. In this video, we're going to continue working on what we've been working on, which is applying deep learning to StarCraft 2. Now, of course, before we can do any machine learning, we have to build our data set, and that's basically what we've been focusing on so far. So up to this point, we've got quite a good visualizations, quite a good visualization of the map and what's going on. I just want to add a few more visualizations, and that's going to be things like how many minerals do we have, how much gas do we have, and then I also want to see a visualization of our population supply. How much of that have we exhausted, like a ratio of that, and then also like a ratio of our military units to our worker units. So we can see on the map usually pretty well like how many military units we have versus how many workers. But things that we can't quite as easily see is like how many units we have compared to our supply. I mean, maybe the network could learn to count the pylons or something and figure it out. It's totally possible, but I thought it'd be somewhat useful to display certain things in like ratio form. So that's the last thing I'm just going to add. And this methodology of displaying things isn't necessarily going to be learnable by the network. I think a bar length is totally doable, like how long the bar is. But in general, artificial neural networks tend to learn more like patterns rather than like a length of a thing. But I'm just going to throw it in there anyways, so just to see. So anyways, I think I'll just do this again. There's not too much point. This should be self-explanatory type code. Let me go to where we're drawing things, and just underneath obs, we will just paste all this. Boom. So what we're going to do is display our minerals. So the game really would have no idea of knowing like how many minerals do we actually have. So that's how I'm going to show it, just with a little ratio of a bar. If we have more than 1,500, then we're just going to show it as like a full bar. And then we're going to do the same thing with the Vespene. We're going to do something similar with population. In this case, we're going to say supply left over supply cap. So how close are we currently to our cap? Again, visually, the network could maybe learn that. But given if units were over it, maybe not. So I want to make sure we have that totally clear. And then I have like a military units kind of ratio compared to our workers. And actually, in this case, this is just military units over our entire supply. And I actually don't see plausible supply. Oh, I do see plausible supply. Okay, line max. Okay, because 200 could be the max. Anyways, I was trying to see if I ever actually use that. Okay, so anyway, then we come down here and then we just draw each line. Then we're just kind of color coding those lines a little differently. So let me just go ahead and run it. I think that the visualization of what's going on will just help quite a bit. As we have done recently, the recent members/sponsors, Onend, Hannes Klumma, Wispario, Howard Liang, and Lizards Mona. Thank you very much for your support. You guys are amazing. Okay, so as you can see here, we have the bars basically, and these are in order. So I purposely flipped them around. So this one here is worker to supply ratio. And then we have the plausible supply. So this is just our current supply out of 200. So as this gets bigger, is it plausible supply? Oh yeah, because we just built a nexus and then it bumped up. So actually supply is, well, yeah, okay. That's our quota. I'm blanking on a good word. Anyway. And then, yeah, like down here, this is how much Vespene we have. And let's just check to make sure we've got a lot of Vespene and not so many minerals. Yeah, so we got quite a bit. And that's usually the case. We spend minerals much quicker, or maybe we're getting Vespene much quicker. I don't know. But yeah. Okay, so now that we've got that visualization, I think the visualization's pretty much done. There are some things I'd like to do, like when the scout flies, you can see how like as it goes up it loses units, and as it goes down it loses units. Again, I'm not really sure if we can get that radius a little larger, because I do like how he like flies around randomly. I don't think I'd want to hold him in the same spot. Another option you have is to just keep sending scouts. Honestly, I just thought of that just now. That's probably a really better, more efficient. Where the heck is it? This one? Yeah. How many spaces? Yeah, so it only takes away one of our spaces, and I believe generally we actually pretty much always have enough supply. I don't think supply is ever an issue until really late game. I wonder about sending like an observer here. Oh, you can't see what I'm pointing to. Get back up here. Sending like yeah, you can see this here, and then you can't see this one, unfortunately. but like up to the you can see this mouse. Okay, so an observer here, and here. Like these are going to be like, if you actually look at these maps, the reason like your start point here has basically a choke point. There's like only one way to get here, and you've got to come through that choke point. And then as you expand out like here and here, there's like 2 points. But then if you go any further than that, it's like you can get attacked really easily. So it'd be useful to at least send 3 observers out at any given time to each of these locations and just always hang one over there. I actually think that's a really good idea. I think I'd like to do that. Unfortunately, I've already begun training data, so I'm going to go ahead and see this one through. But I think if this is anything promising at all, I might want to change the data to something more like that. That would be much more informative, I think. All right, so that looks good. I'm happy with the little bars down here, and maybe they'll be useful, and maybe they won't. Who knows? We'll see. But we won't know. Anyway, okay, so now the last things that we need to do are modify the attack method. I think that's really it. Modify the attack method, and then we actually kind of need to add one more thing. So yeah, so let me. So first of all, I guess we'll do the attack method first, and then I'll talk about the other changes that I've made. So coming down here, I'm just going to replace our attack method with the new method. Boom. I'm going to exit out of that. So what we want to do is we're just going to choose a random choice between 0 and 3. Python's random isn't the most ideal, so you'll notice there'll be a lot of patterns and stuff like that, but it should still, over a long enough time frame, produce at least balanced data. Now, we're going to say target false for now, but if we do find a target, we'll attack that target. And the way we're going to find that target is, if choice is 0, we're just going to weight a random 20 to 165, and then we're going to modify this self.do something after. And we're just going to say that it's the current iteration plus the weight. So self.do something after, I don't think we've defined it here. We'll add that to our init method here in a little bit. But we got one more thing we're going to have to add, so I'll get there. So if the choice is 0, it just means we don't want to do any attack. We want to wait. So this would be a scenario where, ideally the AI would learn that when I don't have many units to send out to attack, it's a bad idea to attack. In general, if you just send like 1 unit at a time, you're going to lose. It's not going to end well for you. So again, just through a simple like evolutionary process, we should find that that's an unsuccessful thing to do. So we should have training data that over time doesn't do, it waits to build an army that's of a size that makes sense for the enemy that we're going to fight. But also, you might need a few less to defend like your little base, but you might want to have 10 at least void rays before you go to the enemy base. But if you're just trying to defend yourself against a smaller little army that they just sent to you just to give you a hard time or whatever, you might not need as many. But also, you might not always want to address when they send like a little fight over to your base. You might want to ignore that and just go straight to their base and decimate them. So just keep that in mind as well, especially if they send their entire army. If you can defeat all their buildings before they can defeat all your buildings, you'd be better off just going straight to their base. So anyways, if the choice is 1, we're just saying, okay, that's going to be attack the closest, or attack the enemy unit that's closest to one of our nexuses. And so we can just do that with the following little string of methods here. So it's just self.knownEnemyUnits, and then closest to is an attribute that's just built in. And then we're just saying closest to a random choice of one of our nexuses. You could iterate through all the nexuses and then figure out which enemy is close or whatever, and that would probably be a way better idea, because maybe they're not close to any of the nexuses. But if that's the case, like if they're really close to one but not the other ones, you've probably expanded really far in the map and you're really late in the game, and it's not a big deal at this point. Like, you've made a mistake if you made it that far, probably. Okay, choice 2 is attack enemy structures. Super simple, just random choice of known enemy structures. Interestingly, random choice. I wonder, I haven't actually seen that error out, but I don't think you could choose a random choice of none. I feel like there should be a try and accept in like all of these. Do I not have? I can't believe I don't have that. I haven't seen myself hitting a lot of errors, but I can only imagine. I guess by the time you've hit, like, you can start iterating through these. Like, the only time we will ever go through these is if we have idle void rays. So I guess maybe that's why it's been so rare. But there's going to be times where you can't make a choice because you don't know of any enemy structures. So that could be pretty problematic. Or that could be problematic like late in the game. Like if there's an enemy structure kind of hidden away and you just never saw it. Should probably try and accept that one, but I'm going to leave it for now. And then finally, 3, attack the enemy start. If we do have a target, we'll attack it. Otherwise, forget about it. And then here we're just making the training data. Again, just like many of our examples in deep learning, if the choice is 0, that means like the 0th element is 1. So we're using a 1-hot array. So we want the neural network to produce an output like this. And this would be 0. It would be no attack. Conversely, if you had something that was like 0, 0, 1, 0, that would be 0, 1, 2. So attack enemy structures. Okay. So that's all that is. All right. So now we've got the data, but then you'll see we're appending the training data to this self.train data. So that's the other thing we want to go ahead and add to. And we probably don't need to print this out anymore. That was just for debugging purposes. So then I'm just going to go up to the top here. And inside the init method, I am going to add a couple of things. So first, we're going to say self.do something after. I'm going to say that's equal to 0, and then self.train _ data for now will be an empty list. And then at the end of it, we're going to save it, but we're going to talk about that in just a minute. The other thing I kind of want to talk about is do something after. I feel like maybe I didn't stress that one enough. So why would you want to wait? Let's say the choice is 0 and it's don't attack. Why am I waiting there for iterations? Well, I don't know if this range is the best, but you want to wait because every iteration we're going to come right back to this question, right? Which one random choice do we want to do? So if you don't force them to wait for some time when the choice is wait, your training data is this option will always be a worthless option because like literally in the next iteration, your AI randomly chose to do something else. But in reality, if do nothing is really the good choice, then you actually probably are going to want to sit there for more than one iteration. You'd want to sit there. You're probably like, if that's the good choice, you should sit there for who knows how long, but some duration. So that's why I want to wait there, because otherwise the wait would be worthless. It wouldn't actually, you'd have such a small chance that you would wait for more than even 1 or 2 or 3 iterations. So I wanted to just do a random range of 20 to 165. And those numbers I just made up. So yeah, because like think about it this way. If choice is 1, what happens? Well, that unit is no longer idle, and it's probably not going to be idle ever again. It's going to die busy. So So that's why we want to make sure that these choices really are balanced choices. If anything, you might want to wait a little longer than that, but 165 is a minute in my times. There might be a way to like reference game time, or you could use the time, you can't really import time unless you play in real time. I don't think I've seen a game time. If someone sees a way there might be something in the bot AI class to reference the game time. If someone knows how to do it, post it below, because I haven't seen it, I haven't come across it, but it would be a better choice than using iterations. Okay, so that is our attack options. Did we add everything we wanted to? So train data, okay, I just wanted to explain, do something after. Okay, so the final thing is we want to be able to reference the result that we get from the game, because we want to save the game if the result is we won. But eventually we're going to want to be able to pit Centibot against itself. So in order to do that and save the result, I feel like the best way would be to use some sort of built-in method that knows who the winner is. Unfortunately, when the game ends, your bot doesn't know it. So that's not very good. So at least for the time being, the choice that we've gone with is to add an Onend method to the bot. So Daniel wrote, basically forked the Python SE2 package and then added an Onend method. So all you really need is one, take that package, and all you need to do is I'll put a link in the text-based version of the tutorial. And all you need to do is just download and unzip the package, put that in your project directory, and it will use that there. Other than that, you probably don't need this. This is where I'm saving the training data on the server, but maybe like here or maybe local here. This might be your Onend method, and you don't need to call this yourself. If you use the updated package, the Onend method is called. Now, other than that, I'm trying to think if there's anything else I need to change. There kind of is. I probably need to pull that package because I gotta test it and make sure it works. So let me copy. I think that's actually this. Copy, paste. Yeah. Okay, so hopefully in the tutorial code now I have the SE2 updated package. So if you download it, it should just be this, and you'll have all this stuff. You might, I forget what he's got in there. I don't know if he modified this for himself or not. I forget. Oh, I modified it. I wonder if I can't remember. Anyway, doesn't matter. So, if you wanted to, by the way, you can import OS and then use something like this. So if your path to StarCraft is StarCraft stuff and then StarCraft 2, you can change your path that way and it'll find the maps for you if you want to change it. But I've modified mine. Okay, so now I think all I would need is import time. And that should be about it. The only other thing is, since I wanted to run this headless to create the data, I also did add a headless equals true. And then down here, I just basically did this, like if not, or rather if not headless. I can't even think straight anymore. Boom. Should be what I did there. Yeah. So if you wanted to visualize data, you could, but I've been running this on an actual Linux server, so we don't really want to see it anymore. Well, you couldn't. It would throw an error if you tried to show it. Which reminds me, when we add stuff to the train data, just take note. We're adding self.flipped. Again, don't screw up and add the resized. It would be a waste of data. Okay. I believe we're ready to run. Let's see. Hopefully I don't hit an error. Oh, or did I? I think I set it to true, huh? I did. So we won't visualize anything. We should see the game though. That won't apply to the pop-up game. I just want to make sure it actually runs. And then if it does, well, it's probably going to yell at me because the directory that I asked it to save in doesn't exist. So Onend train data, I should probably add that in. So I'll just do this new train data. Okay, hopefully it'll save it in there. But also, it will only save it if the result is a victory, which it probably will not be because we're fighting difficulty hard. So maybe I'll change that to easy. Or were we victorious? Has no attribute flipped. Self dot. Oh, wait, hold on. Okay, so. Right. So the other thing at this, the results of copy pasta. So it should just be, you should just need to say self.flipped, boom. And then when you do the resizing, self.flipped. Because we want to be able to access this variable elsewhere. So yeah, that should be it. Also, now we're fighting easy and headless. I'm going to change this to false for the next time if there is another error. Now, regardless of however this pans out, you do not have to make your own training data. I am going to do it. This will take forever to make good data because you probably don't really want to always fight the easy bot. You probably want to just fight the hard one to create good quality data. So that's taking a really, really long time. So I'm running about 100 games simultaneously just so I can collect data at a reasonable rate. And I'll just share that data with you guys so you don't really need to worry about it. But if you wanted to like modify things and run it yourself, at least now you have a good idea of how I went about collecting the data and all of that. So is this our observer? Yeah. So I won't really know until we actually have void arrays. Yeah, like right now it's just our little observer. But that should work, should not throw an error. Okay, so now we do have a unit. Can't find drop off. Okay, that's just for a probe. And I can't recall. I think we're fighting the easy bot. So we should actually come through with a win. It should save the result, and then all I did was just save it under the time. So like whatever the current integer value of the time is what I saved it as. Where is Sublime? There we go. So on that onEnd method, I'm just saving it as whatever the time is, basically. All right, game. Let's hurry up and kill this guy so we can make sure our data saves. It's not looking very well for him. If anybody has a better idea for how we can, let's see, F2. There we go. For how we can, if there's a better way to access the game's result, I know you could say like result equals and then the run game and get the result that way. But then if you ran two bots, I'm just not really sure how you would go about doing that unless you like ran them in a really specific order maybe. And then you could like just know the order. So I'm not really sure, but this is the path that we chose. This game better be over soon. There we go. So onEnd called, we got a victory, and then we come in here and boom, there's our training data. And the training data isn't really all that long. It is usually like 30 to 60 choices max per game. That's why you want to run a lot of games because they take a while. Okay, so that is it for now. The next time you see me, I will have a gigantic training set for you. Well, a sizable training set that's good enough for training neural networks anyways. If you have questions, comments, concerns, suggestions, have I made some mistakes, some stupid choices, let me know below. I know you will. So Anyways, that is all for now. I will see you in the next tutorial.